This is the your turn, number 4 in section 3.4, equations and graphs of polynomial functions. So when we look at this function, we can see that the exponents are 2 and 3. It's in factored form, which is great because it enables us to find the x-intercepts very easily. And when we have an exponent 2 and 3, we know it's a quintic when we graph the function. The positive leading coefficient is 1, so we know the end behavior is going to go from quadrant 3 to quadrant 1. So the y-intercept, we're going to let x be 0 to simplify and solve. So we're going to get y equals 0 minus 1 squared, 0 plus 2 cubed. We'll get 1 and 8, which gives us 8. So the y-intercept is 0, 8. To find the x-intercepts, we're going to take the function and set y to be 0. 0 equals x minus 1 squared, x plus 2 cubed. Now, we don't have to expand this because it's already in factored form. So we're going to take our factors and set them equal to 0. So we're going to get 1 and negative 2. The multiplicity for each is determined by the exponent. So we can see at 1 the exponent is 2, which means the multiplicity is 2, which means when the graph hits that x-intercept, it's going to bounce. For x plus 2 cubed, we know the multiplicity is 3, which means the function is going to hit the x-intercept, flatten, and then pass the x-axis. So let's graph it and see what it looks like. We have 0, 8 as our y-intercept. We have negative 2 as our x-intercept. We have 1 as our x-intercept. We know at 1 it's going to come down and bounce and go back up because we know it finishes in the first and we know it starts in the third. When it hits the x-intercept negative 2, it's going to flatten a little bit and then keep going. I'm going to use a test point here at negative 1 again, because I can see that the y-intercept is at 8 at 0. I know the x-intercept is at negative 2, so negative 1 might be a good spot to plug in. So if I plug in negative 1 into my function, this should be a 1, sorry about that, negative 1 plus 2, I'm going to get negative 1 subtract 1 is negative 2 squared. I'm going to get 1 cubed, so I'm going to get 4. So I know my test point would be negative 1, 4. So I'm going to continue. I'm going to hit that y-intercept, come back down, hit my graph, bounce at my x-intercept, and continue on up. And that's the graph of the quintic.